the panel is already here, so I'm excited for everyone joining. So today with us, three different cybersecurity leaders, I would say, all in their own, all that have their own expertise in their respective topics. And the goal of this panel was actually to combine different expertise and different perspectives about how AI impacts cybersecurity, because there's a lot of different talks in the field, whether it's actually going to, like, even today, I think I heard from someone a joke, will AI take over our jobs? Some working in application security, which, well, I don't think so. At least I guess you, Sandesh, Antoine, and Amit will share my opinion on that. So, but the promises overall sound incredible, and the hype is incredible, and you can use it for both for really different applications, whether you're assisting in secure coding, whether you're solving vulnerabilities, so many different things. And before we start, I also wanted to introduce our panelists today. So first, Sandesh, who's a co-founder of CISO and former security engineer at head of security at Razorpay. He's been in I don't know how many years now.
Long time.
Long time, for sure. And he'll bring our already recorded a podcast together on the Gen AI topic, and really looking forward to hear your opinion now in this panel as well. Also with us, Antoine, who's a co-founder still at Escape. He's a former National Secret Agency security engineer and pen tester, and he often contributes to different open source projects as well, and works. He also built an algorithm, a different machine learning algorithm. So he'll bring his technical perspective to the panel. And also with us, there's Amit Bismut, who is the head of product management at Backslash Security. So Amit's focus is on cloud and application security, if I'm correct. And you also had a lot of product management roles. So what I think you really bring to the table with us today is how how can different security products be impacted when you build them, how AI can actually impact them. So to get started, I think if all of you can share, briefly how you actually implement, different AI models in your organization, what are your goals with them, that would be great. And I think Sandesh, well, you can start.
Yeah. Can you hear me okay?
Perfect.
Okay, excellent. Hey, thanks for having me here. It's already been a great conference. Love the keynotes as well. So I'm the co-founder and CEO of CISO, as you mentioned, Alex. What we essentially do is that we take developer and product artifacts as input, so technical specifications, PRDs, design documents, etc., and we generate security requirements out of them for developers. Right. So that's essentially what we do. There are a lot of other things that happen, which are more threat modeling type things, but this is the core of the product. And the way we use LLMs or generative AI is essentially that it's very hard for regular tools to understand text and images, which is what design documents and PRDs are written with. It's English language plus architecture diagrams, right? On the other hand, LLMs, which are built off natural language processing or NLPs, do a pretty good job at extracting context from these unstructured input, right? So that's kind of why 3 years ago it was hard to automatically generate security requirements from a design document, but it's a lot simpler today, right? And LLMs also have the advantage that it can understand company context, etc., and generate more contextual requirements as well. So that's kind of how we use LLMs at CISO.
Very interesting.
Yeah, Antoine, you can go ahead.
Yes, of course. So thank you everyone for being here. Thank you, Alexandra, for hosting the podcast. So Hinigan, I'm the co-founder and CTO of Escape, and what we do at Escape, we are building an API discovery and security testing solution. And what's innovating using AI in our approach, that the current solution or the competitor, they tend to base their solution on traffic. They have a traffic-based approach, which requires to install an agent, and which is very complex to discover and assess the security of their APIs. While at Escape, we managed to build an agentless approach, which is extremely efficient compared to the traffic-based approach. And I'm going to give two very concrete examples here on how we leverage AI at Escape for those two tasks. Let's take the example of discovery. One thing we do is API discovery from code. So basically, we were able to parse the code, which is either the front-end code or the back-end code that are making some API calls. And from this code, we are able to build back the abstract syntax tree. And from the abstract syntax tree, we are able to resolve the import with a great technology which is called Stack Graph. And from the Stack Graph, we are able to extract from some very relevant snippet of code. And then we feed an LLM with that. And from all of this, we are able to build back open API specifications directly from the code, whether it is the front-end code or the back-end code. So this is for the API discovery. We're also doing business logic testing. And here we have a more classic approach, which is actually a reinforcement learning algorithm that we are using here. And the goal here of the reinforcement learning algorithm is to be able to really generate sequences of requests that make sense according to the business logic of the APIs, and hence really assess the business logic of the different APIs thanks to the algorithm. So those are two very concrete examples of artificial intelligence we use at Escape.
I mean, super well. I think I personally know the algorithm. For those who are interested, I shared in the chat links to what CISO does and what Escape does as well. And I think now it's up to you, Amit, to share with us your goals and your use cases, for the AI.
Yes, sure. Thank you, Alexa, and thank you for hosting me. Really interesting to hear, about other cases and how people leverage LLM. So my name is Amit. I'm leading the product at Backslash Security. In my past, I created several products from 0 to hundreds of customers. And the way that we use LLM and Gen AI in Backslash today, in general, Backslash is all about application security from the code. So we analyze the application code and we find different insights and different security issues and vulnerabilities early in the process so that they could be fixed. And as you know, this kind of domain is not new, but it's an old problem which is not being solved. When we look at the history and vulnerabilities, we can see that the same pattern, the same issues repeat themselves year over year. So we're trying to do things differently. And we leverage LLM and Gen AI in 3 different levels. And I will elaborate more about that later on. But at the deepest level, we innovate with LLM to basically not just find issues in the code, but also understand the business logic and find how things connect. For example, finding that there is a flow in the code related to authentication or a payment service together with some specific vulnerabilities is a toxic combination that is more critical and should be addressed first. And also it makes the findings more accessible for security teams and higher management to understand what is their business logic. So that's being enabled using LLM and Gen AI technology, which really change what we think about static analysis. So with that context, this is what we do, and I would love to elaborate more.
I think business logic seems to be a really thread line between most of the explanations. I think that's something that's really becoming a trend overall in application security. Like right now, since most of the tools allow to test, for very simple vulnerabilities, I think the next kind of generation of tests, and that's where AI will be super important, is very business logic testing. I think, but it is something that's very complicated, and I already seen like in the chat actually the question that we've also discussed before, if there are any metrics to actually see the impact, to see if it's actually helping the model. So if you can share how do you actually measure that impact of the model? How do you understand if it's actually there helping application security engineers, helping your respective use cases? I think, yeah, Amit, you can maybe start.
Okay. So I think that the way to measure things is depending on how you use it. And like I said, we use LLM in 3 levels. So the first level is the way that I think about it is like using it for a task. So if you think about the traditional security posture tools or domain like network security, application security, data security, and I'm oversimplifying. So those domains would take as an input a set of words, a set of inputs, and they would try to classify it into bad or good, basically malicious or not malicious, and so on. And for that kind of task, the requirements would be to have it cost effective, and you want it to be performance effective as well. And you also want the results to be deterministic. You want it to have the same result. And LLM is not the right tool for that task. So LLM is not the answer for everything. It's a tool that you need to know when to use it. But, and here's the big part, in order to generate, or maybe the right tool for that job is to use regular expressions, right? We know them for years, we use them in different places. To generate this list of regular expressions, you can use LLMs. You can easily go and ask to have like thousands of bad inputs, then generate the regular expressions. And for that, you can use LLM. And the way to measure that is to basically, it's more of an engineering KPI, like how would you improve the engineering process of developing that? And one example I can give is that we had a project where we've outsourced a similar task to some organization. It cost us around $50,000. And on the second project that we had, we used LLM, which created the results very quickly. And we just needed to verify the results in one sprint. And now the value is that we save the budget. We remove the tedious task from our developers to do it on themselves. And we got the time to market. We could accelerate the process of developing things. So that's the first level. The second level is to understand the users and their journey. And what I try to do, and this is an exercise that I recommend, is to take a paper and draw the user flow, the user interaction with the product, and try to find all the places where the user interact with text. What I found in my journey, in my product, is that my users, they start using the product, the security team, they use the product interface to find the things that they care about. And then there are 2 points where they have a heavy interaction with text. The first one is that they go to some website, to the NVD website, to explore more about the vulnerability. And they try to get some insights from it. So that's the first candidate where we can use LLM in real time. And the second thing, which was more critical in our business, is that at the end of the day, they needed the developers to fix the issues. So they created some tickets, and in the ticket itself, there is a text coming from our platform. And with the previous text that we had a conversion rate of around 50%. And it's super critical for the security teams, because if the tool or the security platform creates a task which is not clear for the developers, the developers come back to the security team. And then the product, in a sense, it doesn't succeed enough. So we used LLM to basically generate those texts and to create a state-of-the-art, great documentation. And we've improved it from 50% to 90%. So that would be a standard application KPI or product KPI. And that's the second way that we use LLM, which I think is the most important for product management, to understand which KPI your product needs to improve, and then ask yourself, is LLM the right tool for that or not? In some cases, it will be relevant, in some cases, not. And the third level, which is the last one, is to innovate, like doing things with LLM that wouldn't be possible without it. either because of engineering challenges, the data is not structured, mostly because of that. And what we were able to do is to create things that we couldn't do without LLM, basically the business logic thing. And that creates an innovation. And the way to measure that is by the business impact. Like, because you innovate, you now lead. And because of that, you have more customers. And so that's the way that I look at how to measure LLM usage.
Sandesh, oh, Antoine, you have an opinion there?
Oh yeah, no, I think I wanted to follow up a little bit on what Amit just said, and so the first 2 points he mentioned are super relevant, and he already said a lot, and I would like maybe to add some things about the innovation part. So I actually completely agree with the vision that thanks to AI you can now unlock new technological possibilities that you could not do that earlier. As I mentioned at Escape, we were doing API discovery and security. And it happens that this required earlier to have access to the traffic of users, which is extremely painful because it's hard to deploy agents everywhere. It requires to give access to a customer's data, to a certain provider, the security provider, and so on. So indeed, yeah, we can really see that we can measure a real impact in terms of innovation. And we can even see that in the quality of the results in the end. At Escape, we follow two main metrics, which is the discovery success rate of APIs. So some customers, they try to benchmark Escape against other solutions or against other ground truth that they built manually. And we can see that using LLMs as the technology to discover the APIs is extremely accurate, actually. So this is how the first thing we measure. And the second thing is on the testing part, we really try to have a vulnerability detection accuracy, so a reduction of false positives and an increase, a reduction of false positive and false negatives, so in a global increase in quality. And all of this is really related to your third point, Amit, of innovation. And I think that was what I wanted to add over you. Maybe Sandesh, you have some more to tell us about.
No, I mean, look, I agree with what both of you said, right? But I'll make a slightly contrarian point because I know Alex likes contrarian points.
Yes.
Right. I think if you're using LLMs to solve a problem, it's very tempting to measure how the LLM is doing. Right. So if you ever do LLM research, you'll hear about eval frameworks. Anton, you spoke about ground truths, generating synthetic data, building eval frameworks, rack scorecards, etc. Right? But I think you can sometimes miss the forest for the trees. Right? In the end, you've got to measure what you're doing. Right? So if you're building a static analysis tool using LLMs, you got to measure if the static analysis is getting better. Right? And that's the core part. Right? So I think what's really important is to understand what you're using LLMs for and see if that measurement's getting better. Right? Because if your LLM's responses are the only thing you measure and that's improving, but your product is not, or your internal tooling is not, then maybe LLM is the wrong thing to be using, right? So if you only measure LLM responses, if you only use a fancy eval framework, there's a possibility that you're misusing LLMs or you're using it for the wrong reasons and you'll never catch it, right? So the way I think about it is that there is a place for measuring performance of LLMs. At least within CISO, we had to abandon every public eval framework we saw, and we had to build our own internally, simply because a lot of the benchmarks, for example, when new models come out, you see the announcements, they're all for very generic use cases, right? So for our specific use case, we had to build our own eval framework, built off other open source frameworks, obviously, but we had to customize it for our need. But that is something the engineering team looks at, right? The security team, the security research team in CISO and I do not look at that much. We just look at, hey, are the customers getting more benefit out of this? Are the results better? Are they more accurate? Are they more contextual, right? So in many ways, LLMs are a mean to an end. They're a tool, right? Is database monitoring important? Yes. But in the end, you see if your application's working, right? You don't obsess over database metrics. So that's the only nuance I would add. But otherwise, I agree with what Amit and Anton mentioned.
And how would you tie it, to a bigger picture? Because you had experience, the head of security, so you used essentially products that contained LLM. How would you for example, set the goals, the bigger picture goals, of usage the products within the LLM for security purposes?
Yeah, I think that's a really good question. There's a key difference between building products for the world versus using LLMs for your internal use case, right? So two things. So one is that it's hard to build general purpose tools using LLM, but it's pretty easy to build something for a specific use case in one company, right? So when you're building an internal tool, you can supply some internal documentation, you can train the model, you can fine tune the model with your internal toolkit or your internal source of truth, and then get better responses from LLMs, right? Whereas when you're building a product for the world, like we are at CISO right now, I have to make sure that it works for every customer. So there are certain things you cannot do because you don't have access to those internal documentation of every customer, right? So I think if you're a security team, so when, for example, if I wear my former head of security hat at Razorpay, right? The advantage we had there is that we had the ability to, supply the model with internal data and then get better results, right? So you should always focus on solving for your use case, make it more contextual, just supply more data that in a way that you can, supply more clean data, and so on and so forth. The disadvantage though is you don't know what the world is doing, right? So when we kind of build a product for the world, a lot of the focus is actually on the user experience. Because the UX for an LLM-based application is usually very different from a general application. There's a reason why most AI applications or LLM applications are either a chatbot or a copilot. Because in both cases, you get immediate feedback from the user, right? You type a question, you get an answer. If you don't like the answer, you give feedback, right? Same with Copilot. It suggests a piece of code. If you don't like it, you change your prompt, right? So those kind of UXs work very well for Gen AI. So if your product does not have the use case like ours does not, we have to really rethink about what the user experience is. We also have to think about, for example, explainability, right? When you give out response, you have to figure out why the LLM said what it said. Otherwise, how would you know it's not hallucinating, right? So I would say those are the two key differences. I think when you're building it internally, you should really focus on, supplying more internal information to make the responses better. And when you're building for the world, you have to focus on user experience a lot more, especially things like the interface as well as the explainability.
Yeah, makes sense. Makes sense. And I think like talking about the specific use cases, both for you, Amit and Antoine, I think both on Escape and Backslash Security, they offer AI-powered remediation guidance. And can you explain a little bit more how it works and how you measure the impact there?
Yeah, okay. I can start quickly. So what's important to understand that at Escape, we have a dynamic approach of security, where Backslash has more a static approach of security. So they have a strong access to the source code that is, I think, very interesting to produce smart remediations. At Escape, as I mentioned earlier, we're also able to access the source code and to see where, when we detect a vulnerability dynamically, we try to match it with the right place at the source code. So this is very related to the API discovery from code that I mentioned earlier. And here, the LLM is extremely useful, not necessarily to build the remediation, but just to find the right place in the code where the vulnerability we found dynamically is actually coming from in the code. So making this link and bridging this gap between dynamic and static is where we do leverage a lot of deep tech. So there is not only NLM, but as I mentioned earlier, IAST parsing, dependence resolving, stack graph technology, which is an open source project developed by GitHub. And then the LLM is able to make this link between the remediation, the issue, and the issue we detected and the code where where you should fix the problem actually. And then from that, you're able, from the LLM, to suggest remediations as merge requests, for example, which is extremely relevant. But I'm sure Amit has a lot to say about that, so I will let him go for the static part.
Yeah. Okay. So let's talk about code. So at Backslash, we have access to the code itself, and you would imagine that having the access to the code would immediately give you like the perfect remediation. And some people will not like it, but my answer is no. So there are some companies who are doing that today, And based on some user research that we did, we saw that it doesn't work. It doesn't work in the way that you would imagine, like automatically fixing issues and trusting it to fix the issues. A lot of it depends on having a good test coverage to be able to blindly trust what the suggestion would have, and most customers don't have that. Like 95% of them don't have test coverage for everything. So, even if we look at startups that are only doing remediation for code, they started using LLM and then they try to move away from it as even a message, because I think that you want to have a deterministic result, which is safe. And one of the problems with LLM is that it might suggest different results on every time that you run it. Even though there are different features that supposed to fix it, it's still not stable enough. So this is a very natural process in our product. We find issues and our customers need to fix them. So we do have to create a solution. So we moved away from automatic fixing. We tried that. The approach that we now use is to have remediation advice, which is using the context of the code. For example, whenever you have some vulnerability, the way to fix it is not necessarily to just change a parameter from 1 to 0 or something simple like that. In some cases, you want to add a middleware that addresses the issue, different frameworks that are relevant. And in organizations, usually they already have some of those frameworks implemented in other places. So I would say that the trick with LLM is to feed it with the right context to get the relevant results. And what we found here is that the solution is to create a contextual recommendation, including the context from the organization, like the technologies that they use, the databases that they use, and different middleware that can address the security issues. So the recommendation that we provide are relevant and are for the specific language, the database, the framework that they use, so that they could basically have the most proper recommendation that would work for them and do the fix.
I don't know if time allows, but I have a small question for you, Amit.
We have 3 minutes left. I'll just ask the audience if anyone has any questions, please ask in the chat. If not, I think Antoine is going to ask his question for the remaining time. Let's wait. I think you can ask your question. At least there seems to be no other, and we'll wait to see if someone else.
Thank you very much, Alexandra. I have a question for you, Amit. How, when you detect a vulnerability in the source code, how do you make sure that this vulnerability ends up being exposed on the internet and a real problem for the customer?
Yeah, so good question. Basically, you can't really do that from the code itself, because network exploitability is something that is not determined in the code. It's mostly in the service, in runtime, in environment variables, and sometimes in the in the WAF, in the firewall of the organization, and so on. What we can do, and the best thing that we can do from the application code, is to find a flow that is exposed, like having an endpoint that exposed eventually a log4j package, right? And then with that context, we can work with LLM to understand more deeply what we know about this flow.
Very interesting.
And I would add that I do believe in remediation, but it's not just remediation. I think that whenever a code is being written in the first place by LLM, it should be secured. And if the model is trained on a secured code in the first place, so we wouldn't have SQL injections and issues like that.
Yeah, of course.
Can I ask another question to Amit, since we're all asking Amit questions?
Sure.
Let's go.
Go ahead.
All right. So you raised an interesting point, right? About LLM generated code being automatically secure. The one thought I've had is, should we have different standards for LLM generated code versus human generated code? Simply because I can't bother a human with 10 Jira tickets and 10 iterations of, hey, did you do this right? Did you do that right? Right? They'll get annoyed. Their time is valuable. Whereas I can ask 100 different questions to a code generated by an LLM to make sure it's secure. So do you think there's value in kind of saying, figuring out saying, hey, if it's an LLM generated code, you have a slightly different workflow? Or does it not matter because in the end, the code is owned by a human and they are responsible for the security of what's being deployed?
Amazing question. Recently, Google announced, I think it was Google, that 25% of their code is being written by LLM, which is amazing. And if you think about it, imagine that this LLM is a single developer. And now, as a security team, you can enforce different standards on that 25% of the code. So I think this is the answer. We need to have agreement between development and security team. What are the frameworks and standards? And then from that moment, we can define that as a context for the model. And for every code that is being generated, it would use those contexts. For example, using sanitization and using specific frameworks. Now, every code that is being written will be written with that security built in.
Makes sense.
Yeah.
Okay, I think we're perfectly on time, actually. So thank you so much, Sandesh, Antoine, and Amit, for sharing your insights. I think the audience was really expecting to see, actionable metrics. We get. Unfortunately, I'm not sure we have time to answer the question, but it's a really good question, Eduardo. So thank you so much, if Antoine, Amit, and Sandesh, and I will. Just a reminder for everyone who is watching. Each session is recorded, so if you need to rewatch certain part, you can just connect it back to the event and rewatch it afterwards. And we'll also publish the talks on YouTube eventually, not straight away, but the Elephant in AppSec channel when we have a little bit more time. Thank you, thank you so much, and great to see positive feedback in the chat.
Thank you.
Merci.
Thank you, everybody. Bye.